Right, let's do a bit of integration by parts. So that was working backwards through the chain rule.
Mm-hmm.
Now let's try working backwards through the product rule. Where's it gone? Yeah. Right then. So, because if we were going to try the chain rule here, just let's make sure that it doesn't work. Let's try it, it'd be no harm. So we've got to find the integral of that, which is what that says after all. You've got an opening bracket and a closing bracket. So we're trying to find the reverse derivative of x sine x, because the brackets there just mean integral of, reverse derivative of. So if we put the thing it's of down the bottom, and we want the reverse derivative of that. Well, I mean, what could we choose for an inner function? It can't be x because it never is, then it wouldn't be a chain rule. So it must be sine x is an inner function, but then that would have to be a half sine x squared, which would differentiate to give us cos x, but not x. It's just and there's no way of repairing that.
Yeah. So it's not x is the inner one and sine's an outer one.
Well, yeah. Okay. Let's try that as well. So we've seen that it didn't work for sine x. Fair enough. But then up here it would need to be half x squared. So we didn't need the chain rule there because the inner function is just going to be what?
X.
No?
One.
One, you mean? Yeah. And then where's the sine x coming from? We've got no idea.
Yeah.
So we can't make this equal sign operative.
Oh. Yeah. Not if you add sine x on the bottom.
Add sine x on the bottom. Ah, now that's a very good idea. Yeah, let's do that. So a half, because this is an important point, the fact that you can't do this. So you've got times 1, and then you're saying, okay, so that's sine x. But then surely if that's, you know, if we're changing that, surely we should put that up there or something like that.
Yeah.
Is that what you meant?
Yeah.
But then when we check by differentiating, we'll find it doesn't work at all. Because when you differentiate a product, you've got to apply the product rule. Anyway, so no, it doesn't work. You'll understand soon why that doesn't work. Because when you try and differentiate it, it's just something else entirely. Because when you differentiate with a product rule, well, what was it we had up there? We had sine x times half x squared. Now, if we differentiate that, we'll find out we get nothing like that. What do we get?
My mum was just wondering what your house number is.
Oh, we don't go into 27. Anyway.
27.
Cool.
Right.
Great. Um, um, uh, bless. Right. Cheers. And so, so do you recall this arrangement?
Yeah. Yeah.
This is what actually happens with a differentiating a product, isn't it?
Okay. Yeah. So
So you'd get.
so sin x there, or even
Oh,
cos x.
sorry. Well, you might. But in my diagram, I put a line there to show that I'm actually differentiating.
Okay.
So yes, we could have left that one alone, but then I'd put the legs like that, and that's fine. So I just have sin x there. Half x squared would differentiate to.
X.
Oh, good then. So we get that. But the trouble is,
Yeah.
we also get this, which would be what?
Which would be half x squared.
Would be left alone. I want to put that there so I can
And then
differentiating signs again.
Cos x.
Cos. So that would mess things up.
Yeah.
But because the product rule is involved, we can use the product rule to integrate, which is precisely what we're going to do. Okay, so we've got x sine x there. Okay, so x sine x equals x sine x. So far, so good.
Yeah.
What's the integral of sine x?
Minus cos x.
Minus cos x, good. Where the bubble is like brackets, so it's implied that there's a times sign there, yeah?
Yeah.
Not just subtract. So what goes in here?
X.
Just x itself, because, you know, that's the logic of the product rule.
Yeah.
Oh, right, but it is a product rule, so now we have to complete it, don't we?
Yeah, so there you're gonna get 1.
And then here we'll have.
And here we'll have minus cos x.
Minus cos x left alone on the way down, differentiating.
Yeah.
Right. So, okay, what we're trying to integrate is that, which is that. Oh, and we've got this, the integral, but the trouble is what we've integrated here is not just that, but it's all of that, isn't it?
Yeah.
So how can we make that right? How can we restore this equal sign so it's equal, so it works again? How could we make this equal to that again?
Subtract 1 and add cos x.
Yeah, again, there's an invisible time sign there. I left them a bit dangerously.
Yeah.
You know, they're brackets really, aren't they?
Yeah, so subtract 1 times minus cos x.
Yes, which is like, we can simplify that. Subtracting 1 times minus cos x is like doing what?
Subtracting minus cos x.
And subtracting minus cos x, we could even simplify that to?
Adding cos x.
Sorry, yeah.
Yeah.
Just adding cos x.
Yeah.
So now we have got x sine x here, haven't we? I mean, we're taking cos x, but then we're adding cos x. So that's fine. So all of this is just x sine x.
Right.
So if we have the integral of all of that up here, it will be what we want. It will be the integral of x sine x.
Right. Okay.
How can we make this the integral of all that?
Add cos.
Add
Oh
cos.
no. Add sine.
Sine, exactly. Yeah, perfect.
Yeah.
All of this here is equal to x sine x. It's just
Mhm.
written differently. And the integral of it is exactly that.
That. Yeah.
Makes sense? And that's
Yeah.
called integration by parts. God knows why. Parts of a product, probably. I don't know.
So this is the product rule.
Yeah, absolutely. We're working backwards through the product rule. It just
So
needs
find
this kind of adjustment
yeah.
here. Sorry, say
So,
again?
so basically do the product rule and then
Yeah,
add on anything
yeah,
which do what we usually do, add on anything which is
yeah.
needed.
In
Yeah.
general, it'll be you'll think of it as subtracting, but we subtracted a negative, so. And in fact, the formula is no. And I can be tolerant of the formula, but there's just no need for it here. So
Okay.
we'll do some more of that next time. I mean, you see the logic of it, and it's
Yeah.
even easier than the chain rule, I promise you.
Okay.
And
Okay.
you're getting the
Good.
chain rule now, aren't you?
Yeah, no, this is definitely going to help a lot going into because I'm about to study this at school after Christmas, so
You're about to what?
I'm about to study all of this
Yes,
stuff.
quite.
So
Oh, yes, and I better prepare you so that you're not so that you do understand if people start showing you something that looks completely different, you'll know that it's exactly the same thing, and you won't be thrown by that, I hope. Yes.